Okay, Joel, looking at your model, which I've basically modeled exactly the same way as you did on your YouTube video, the big problem comes into it when you start to make some changes. So for instance, if we change the elevation of the object from 150 down to 105, for instance, and we finish that, because of the extrusions we've got with all our holes, we start to end up with some really ugly results here. Other issues could be if we change the inside diameter from say 50 to 60 millimeters, finish the sketch. All our pins can move in, the holes down the bottom can actually be starting to go through the walls, and stuff gets really ugly. We start to get some gaps in here, so it makes resizing the object extremely difficult. So this is where we need to actually be using proper constraints. So if I was to remodel this from scratch, using the way I would do things, I turn my origin on. The first thing I actually always look at is a couple of key pieces of information. What I want my overall height to be, what I actually was thinking about the outside diameter of the base of the object, the top diameter of the object, the inside diameter, our wall thickness. We've got that top vertical that you've had there of 5 mils. The drain holes, I want them to be 5 millimeters in diameter. The drain hole spacing, so how far apart I want all of those holes up the wall. The number of holes we have up the actual wall itself. We've got that lower offset that you had in there for 5 mil, and the upper one you had is 50. And the other thing I consider is the actual layer height that I'm printing my object at, and I'll show why I actually have those values for later. Now what I actually do when I start to do these things is I actually use the parameters tab. And with this parameters window, allows me to create information that I can easily change without actually having to go back into sketches to actually make those modifications. So I'll go through and I'll put this information in now. So I'll put my height, it's in millimeters, and I'm going to put 150. I'm going to add a parameter for the base diameter, and I'm going to set that at 120. I'll add my top diameter, 240. I'll add my inside, and I'm going to set that at 50 millimeters. And then I'm going to have my wall thickness. I'm going to set that to 2 millimeters. I'm going to add my top vertical. That's 5 millimeters. Drain hole diameter, we were setting that at 5. Drain hole spacing, and we'll set that as 10 millimeters. Drain hole number, I'll just go num. Now it's important here we change this from millimeters to units because we're putting in a quantity rather than actual distance. So we're going to say we're going to make that 10. And then we're going to have our offset, a lower cup. And that was 5. And we'll add the other one, which is the offset upper cup. And that was set to 50. And also we're going to change the layer. So this is our 3D printing layer, and I'll explain why we'll do that later. So we're going to go OK to that. So once again, I'll create my sketch. I'll draw a circle from the center out. I'll dimension this inner here, and this is now my inside diameter. So that's now set at 50 mil. So at any time I can come up here and change that to 60, and that automatically changes it. So later on, I don't need to go finding which sketch I dimension that object into. It's all here in this table. Once again now, this time, I'm going to draw a line from here up, and again a line from here out. Now previously, as you remember, if we look at this strawberry pot, we ended up with some gaps in here. And that's because what we didn't do back in this sketch, because we didn't constrain this, which is basically anything that is still blue is unconstrained. Once it's black, it's constrained and fixed in location. Because that was unconstrained, we can end up creating gaps. We go back to our new model. Now what I want to do is, if I put it, we know that if it's in the middle, and we have a wall thickness of 2, we'll end up with a wall here of 2 millimeters and a wall here of 2 millimeters. But the problem is there, what we want to do is actually merge those two walls and keep this wall between the two of them exactly the same as the rest of the wall at 2 millimeters. So what I'm going to do is I'm just going to move that down for there, and the same here. As you can see, I've already preempted that and moved that up here. What I'm going to do is draw a line from here out and from here to here. Also too, I like to make mine construction by just clicking on the line and pressing X. And now I'm going to dimension this line from here to here, and this is going to be my wall thickness. But what I'm going to do is I'm going to divide that by 2. And the same here, there to there. I can go wall divided by 2, which works. The alternative is I can actually select this dimension here, and it's the same. So once again, if I was to go down to my wall, change that to 5, that changes to 2.5. So that's all automatic. Once again, I'll dimension this, and this is my offset on the lower cup. And to keep it simple, I'm just going to say that equals that. So there's my 2 lines there. Once again, I'm going to hit the X, and I'm going to draw a circle this time, and I'm going to go out here, and I'll dimension this here being my base diameter. Now when I draw my arc of 3 points, click on that point, click on that point, and I say it's a tangent. Well, I've done that construction, so X, and bring that back. Turn construction off. So now I've got exactly the same thing, but now everything is black because now everything is constrained. So if I change diameters of any dimension in that table under the parameters, well then that'll automatically change this without having to come back into the sketch to try and find it. So I'll finish that sketch. Well, from this plane, we want to create our overall height. So I'm going to hit my offset plane, and this time I'm going to go change that to height. So now I've created that plane, and once again, that is a parameter that's listed in the parameters tab. I'm going to create my sketch. This time I'm going to project my inside diameter. And I'm also going to project this line and this line because they define where that outer edge of the wall of this go. So I don't have to redefine all of that where those lines need to be. This time I'm going to draw a line from here up, and a line from here out. Once again, they're black, which means they're constrained to an object below. I'll dimension this one here, and this was my offset for the upper cup. Once again, I'll use the equal button to make them equal. Turn on my construction. I'll draw a circle from here out. Once again, we'll dimension this as being my top diameter. Turn my construction off. I'm going to do my 3-point arc again. 1, 2, and then I'm going to select tangent here. So if I decide that, oh, that's not quite enough, I could actually in here change this up to being, well, we've got the top diameter is 240, I might make that 260. And that automatically drags this circle up and down accordingly. Then we go finish sketch. So now if I look at it, I have my two sketches, my upper and my lower. Because I defined my whole object as being 150 mil high, I actually want the 5 mil vertical that you had to actually be down from that surface rather than being up. So I can select this and I can hit E for extrude, and then I'm going to go minus the top vertical distance. So there's our 5 mil. So now I can create my loft. I can select that object and select this object. And once again, I have exactly the same shape as what you did before. However, I can actually say, well, I don't like that sharp edge here. I'd love that to be nice and curved. So this up here is profile 2. So I can change that from connected to tangent. So now I end up with a really nice curve finish to that, but I do know that that last 5 mils is truly vertical. So now I can do the same thing as before. I can shell this, and the shell dimension is wall. So now I've created that shell. Once again, I can do what you did before, which is create the tangent or the plane through here to put the first hole through. And go OK. Now I can create a sketch on this surface. But what I want to do is I want to start my first hole 10 mils above the inside of this actual object. So what I can actually do with the projection, if I hit project, I can actually go in here now and actually select the inside and go OK. So that's brought me that line there. Then I can project this surface here. Okay, so I actually end up with the two projections straight away. So now I'm going to create a line from the midpoint of here up to here. Once again, that's my construction. I'm going to draw a circle here, and I'm going to dimension that as my drain hole diameter. And what I'm going to do is I'm going to click here, and this one's going to be drain hole spacing. So that's starting now. The center of that is 10 mils above the inside of my object. So if my wall thickness was to go to 10 millimeters and make my walls 10 mils, that will push that up 10 millimeters. I don't actually have to go and modify this because as the wall thickness changes automatically, it will push that up. Once again, it's all black, so we know it is constrained. Finish sketch. So now I can actually select my circle here, and this time when I extrude, I'm going to extrude it through. And if I extrude it through like this and do a cut, that's great. The problem is at the moment, I'm actually only coming through by this amount. If I was to actually make my inside diameter much larger, the problem is my cut actually doesn't come through the actual object. It might end up a little bit short. It's more obvious if I do it to there. The problem is obviously if I make this diameter, say 15 mil larger, well, this cut actually doesn't actually intersect it. So to ensure that I always intersect it, I say exchange it from a distance to an object, and now I say to this surface. So it doesn't matter where this surface ends up. If the wall thickness changes, the inside diameter changes, it actually keeps extruding to this surface. And I go cut. So there's my first hole. So now I actually want to create the other two holes around the outside. Now you did the selecting the object and you copied it and rotated each individual. I actually used a circular pattern, but this time I actually want to do a circular pattern on the face. So hit the circular pattern, the faces, one object is selected. Now I select my axis. And instead of being a full, I'm going to do a symmetry, and I'm going to set that at 45 degrees. And I go OK. So now there's my three holes. Now I select my three holes and do a rectangular pattern, directions up, quantity 10, And instead of extent, I'm actually going to go spacing. And my distance here is now the drain hole spacing. So there we go. So there's my 10 holes up the face. Now that actually is working at the moment because of the height of my object. If I actually went and then function and then changed my height from 150 down to, let's say 120, that still works. If I was to change that down from height from 120 down to say 105, we start to get this scenario where we've got all our holes, or even if I change that to 100, we get even worse. We start to end up with this scenario. So what you'd like Fusion to do is actually put the number of holes in, but not actually cut like this. You always want to leave a gap at the top. So we can actually use some automation in here to actually define how many holes we actually have. So if we want to get really advanced, we go into the function and we go drain hole number is 10. So what we could actually do here is change this to, well, let's say we can actually start working this out and we can divide how many we have. So I can open the brackets and we can go take our height, and then I might subtract my wall thickness. I'm going to subtract my top vertical. And then what I can do is divide that by our actual spacing. So that actually works out to 9.3. So actually, if I come in here and change my height to say 150, it's worked out it can put 14.3 holes in there. But obviously we don't want 14.3 as a spacing. So what I can come back into here and go floor, so round down, extra bracket in there, the floor of that whole amount. So it's now 9. So it doesn't matter what I change my height to, it actually calculates out for me how many holes it can fit there. But I want to actually have a little bit more gap at the top. So what I'm going to do in here is I'm going to go minus, I'm going to put another drain hole space in there. So basically it works out and then subtracts one hole. So now that becomes 13. So what happens is now I can actually change this from 150 to 100. Oh, sorry, we'll go OK first. And then what we can do is in here, change the quantity from there to drain hole number. So now I can change my height to 150. It increases the holes. If I was to change that height to 80, it reduces the number of holes. And that's all automatic. I don't have to think about it. I don't have to change it. It's a function that's automatic for me. Once again, thanks to Angus, corners create cracks. So what we'll do is we will fill it here and here, and we'll give that a 5mm radius. So now we have our dynamic flower pot or strawberry pot. So once again, I'll do my rotational pattern. This time I'm going to select bodies. I'm going to select my bodies, axis, here, number 4, okay, and we end up with our nice flower pot. Need to merge all of these, so I select my primary body, combine, select 2, 3, 4, okay. So there's our nice flower pot. I might make things a little bit, now I'm going to fill it here, fill it that edge, that edge. I'm going to put a 5mm fillet in around those. Excellent. So now, once again, I can change any of my dimensions. Move this over, and I can make this 120 mils high. I might increase my outside diameter to 300, depending on my printer. 240. I might make this, let's come down to 100 mil, so I can shrink the size of the base. If I decide that my inside diameter needs to be greater, 60mm, very simple and easy to change from one location. I don't have to go searching which sketch I actually had all this into. My drain hole spacing, once again, I can go, well, there's 10 mils, I actually want them to be 15 mils. So it actually then, as you can see, it automatically reworked out and computed that I can only get 6 holes in based on my formula. I can change my drain hole diameter from 5 to say 8mm holes if I think they're too small. So it gives us a nice dynamic way of actually handling all of this. Now with the actual joining of the pots, there's 2 ways we can do it. We had the pins. So what we need to do is obviously we want to ensure that when whatever pins we put through are actually going to work, regardless of how much we change the inside diameter here. So if we make this larger, well, we need those pins to then move out. So once again, what I'm going to do here is I'm going to create a sketch on the bottom. I'm going to project the bottom. Also, what I want to do is project, and I want to know where this inside edge is going to be. So if I project, easiest way to do that is the top surface as well. So if I turn the bodies off to make it easier to see. So there's our inside of our circle. Here is the inside corners of the flower pots. So what I'm going to do is I'm going to create a circle. And we're going to go out here. And I'm going to turn this as a construction. Now I want whatever holes we make, I want them to actually be basically just clear of the object. So what I want to do is make sure that the outside edge of whatever pins I create and the holes I create are always inset from the actual wall of this. So if I dimension here to here, and I say at least, I'm going to say 1mm, so it'll always be that. Once again, I create a circle from here to here, make that a construction. What I'm going to do is basically work out where I'm going to put all of my circles. So I'm going to create a line from here through to here. I'm also going to create a line from here through to here. And just because of the geometry of it, these will always be basically at the 45s and on the centers. Once again, I'll select these lines, make sure they're all construction. So this time I'm going to draw a circle here, out, once again out here, out here, out here, here. So these are basically creating our holes. So what I want to actually do now is actually make sure that I can add my pin diameters. So I can go pin diameter, and I'm going to make them 4mm. The other thing I can do is add another one called clearance. And I'm going to make that 0.2. I'm going to go OK. So what I need to do is select this one, this one, this one, and this one, and say they're all equal. I'm going to select that one, that one, that one, and that one, and say they're all equal. So now I dimension just one of these, and then this is going to be my pin diameter. This one here is going to be my pin diameter plus my clearance. So there we go, 4 and 4.2. So once I can print these, I can test and go, decide whether those clearance is enough or not. Now the last thing I want to do, as you can see, these are still blue. So basically this circle can move in and out. So now I can actually just hit the tangent button, and I'm going to make here to here. So that's a tangent. And the reason I've tangented these ones is not this one, is basically as my pin diameter increases and my clearance may need to increase, I'm always ensuring that there's 1 mil between the inside wall and the outside of the hole. So now I'll select my holes. I'm going to extrude that, turn my bodies on, to object, here, cut, OK. So there's my 4 holes in the bottom. Now, I actually want to do the pins on the top. So this time, I'm going to select my holes. I could have made this construction on the line work of the projection, but a couple of seconds to do that. Obviously, I want to extrude though, this time up here. So now if I hit the extrude, I'm going to go, instead of starting from profile pane, I'm going to say from object. Now I can select that from the object direction. I'm going to go 2 sides. And what I'm going to do now is I'm going to project this down so I can go, well, that's 5 millimeters. But this time I'm going to put it, and then I can say I can put up. I can say I want it to go up 5 millimeters as well. Or I can say the distance, I want to make sure that these pins always protrude through the base. So if I can check which one's that, so this is the bottom one, I can actually say wall. So now these pins will always be, or it could be wall plus 1. So there'll be always the wall thickness plus 1 mil further on. And this is going to be a join function. But as you can see, my pins are 4 millimeters wide, but my wall's only 3 millimeters, only 2 millimeters thick. So I end up with this overhang, which will make it difficult to print. So if I come back up in here, and I might put a taper angle in here as say -30. So what I've done now, so as to turn this body off, is I've created tips on it. So now if my wall's only 2 mils thick, it'll taper down to hit the wall, or if it's too thick, it'll actually just basically be absorbed into the join. So now I hit join and I go OK. So now I have my pins. I can now hit the chamfer command here, here, and here. And this is where I like to do my layer, and I want to do it for, say, 4 layers. So now I know that that is going to be 4 layers thick of chamfer, or I can say I want to be 3 layers thick. And okay, so there is the completed flower pot. Turn my sketches off. So once again, I can sit over here, function, as I change things. So if I make my inside diameter 60, straight away everything moves out with it. 50. If my wall thickness was to go down to 1 millimeter, it doesn't matter because I've got the taper, the actual pins are supported. Or if I go to say 5 millimeters thick, the pins also extend to get through the 5mm thick base plus the 1mm, but now you don't see any taper. So everything's dynamic, everything is easy to change, and if you decide you want a larger pot or a smaller pot, we can do that very simply with no problems with constraints. For me, I just like a more simpler way of stacking it, because sometimes I may want the pots maybe to line up, or I want them to do a little circle and only not exactly 45 degrees, it might be only 30 degrees. So what I'd actually do is, for me personally, wouldn't use this. So just going to get these things out of my timeline because I don't actually want them. Actually, I don't even need that whole sketch anymore. So what I'll do now is I'll create a sketch on here. I'm going to project this surface. So I'm going to turn the bodies off just to make it nice and easy to see. We look at this again. All right, so what I'm going to do is I'm going to do two circles. I'm going to do a circle here and another circle here. So I'm going to dimension this. I want this here to be 2mm thick. And then because I'm going to do is I'm going to create a sleeve to slide up inside the unit above it. So I know from practice that around 0.2 of a mil, or the value we have, which is clearance, works quite well. So what I can do now is I can select this object and this one, and we're going to extrude down, and let's go, don't have to go too far, 3mm. We'll turn that body back on, and we're going to do a join command. So it's created me a lip. So obviously we can't 3D print this edge. So with the overhang without support, so we're just going to create a chamfer on that. So it's going to be 2mm plus our clearance. So if we change that clearance value to make the fitting of it just a little bit easier, I don't actually have to think about changing this fillet. We know that it actually, chamfer, we know that it actually is still going to be valid. So if I turn the sketches back on, turn sketch 6 on, now I can select this edge here, and I'm just going to go extrude, and I'm going to say, this time I want this to go 5mm. So now it's creating a 5mm wall, join. Once again, to make life easier for the fit, I will select that, and this time I'm actually going to put in here, once again, layer multiplied by 3. So it's going to be a 0.6 chamfer. And if I wanted to, I could come down here, select this edge again, chamfer, layer, multiplied by 3. So for 3, we're going to 3-layer chamfer on the bottom of it. So now basically one slots into the next one. It doesn't matter how many we do, they keep on stacking. These edges will support the one, and I can actually slide it on there and rotate it at any angle I like.